I welcome you all to this session on drilling and milling. In the last session, we have studied about machining using a single point cutting tool. But in this present session, we will be studying about drilling. A single point cutting tool is the one which has a single cutting edge to remind you all, whereas drilling uses a drill bit in which it has two cutting edges where those two cutting edges will be participating in the material removal process. Now here this drill bit has a rotary motion. It has a rotary motion. At the same time, feed is also given to the tool. So in this particular operation, by using this drilling operation, we can produce holes. Now this drilling operation, there are different like as you all see for example a drill bit, you'll be seeing a drill bit, you can see making holes or producing holes by using a drill bit. Now how does that work? It has two cutting edges which will be removing the material. Now due to the rotary motion of the tool, the cutting edges will be going penetrating into the workpiece, thereby the stresses will develop at that particular point, and at that particular point the material will be lost from the surface. Like here you can see a video. In this particular video, you can see a tapping operation, which is a kind of drilling operation or one of the operations of drilling. There, the material will be removed. Now, here, if you observe in this present, whereas if you see in this particular tool, this is one of the cutting edge and this is the other cutting edge which will be participating in the material removal process. Whereas you can see an area on this surface, a groove like structure where this area uh, is provided to remove the material which is removed, that is the chips. The chip will be flowing through this surface. On this surface, it will be moving or coming outside of the. So, since if it is like the whole thing is provided in the form of a cylindrical, it is very difficult to remove the chips which are removed from the surface. Since that is the reason we provide a flute. This region or this area which is provided in this form is called as a flute, where it is made in this manner so that the chips are removed easily from the during the machining process, during the drilling process. Now this here you can see this present video where the chips are coming out from the surface. The chips are coming out from the surface. Now if you see this present drilling operation, now drilling operation can be performed on different machines. Like if you see, you might have seen lathe machine, where by using a lathe machine we can also perform drilling operation, that is by placing the tool to the tailstock. By placing the tool to the tailstock, you can perform the drilling operation, which we have seen in the last session, a video showing the boring operation. Before boring, a drilling operation has been performed in that. So you can refer to that video. And there are different operations in drilling also. Like you can see reaming operation, tapping operation and counter boring operation in the present slide. Now what are these operations? Why do we go for these different types of operations? Why like what is the use of these operations? Like if you see in this reaming, the first operation which is related to drilling, a kind of drilling. Reaming is an operation where it is used for finishing the drilled holes. Reaming is an operation which is used for finishing the drilled holes. Now, what is the need for finishing of these drilled holes? or like finishing is nothing but the size of the hole will be little enlarged. What is the need for this? The reason for this is here drills are available in a standard sizes. Drills are always available in a standard size. Now, if you go for drilling operation, now since the drill bit is available of a standard size, whatever the operation which you do by using that drill bit, you get the standard size. But for the requirement, if you require a like the drill bit available is of some standard size of 10 mm, but you require a hole that has to be of 12 mm. The standard size, if it is not available, then we go for these secondary operations. In drilling, these are the secondary operations where the hole size can be increased. Now, by using a drill bit, you get a standard size of the hole, but by other secondary operations or other different types of drilling operations, you can enlarge the holes. Right? Now, reaming is mostly meant for finishing the holes which are already dead. Now, here you should keep in mind that reaming is not an operation where you can produce a hole. Dreaming is a secondary operation which is done after the hole is drilled. Like here, once the hole is drilled, now that hole can be enlarged by using a reaming tool. Now that is the difference between a drilling operation and a reaming operation. Now drilling can, by using a drilling operation, you can produce a hole, whereas reaming operation is only meant for enlarging the existing hole. Right. If you see the other operation, like in the last session, we have still seen boring operation. Now, in a boring operation, now how the hole, it is also meant for producing or enlarging the hole. Right. Now, what is the difference between a reaming operation and a boring operation? A reaming is the one which uses a multi-point cutting edge. Multi-point. Right? You can see the cutting edges on the surface of the tool. Like it has multi-edges, multi-point cutting tool. Whereas in a boring operation, you can will be using a single point cutting tool to enlarge the hole or to enlarge the existing hole. So that is the difference between a reaming operation and a boring operation. Now, if you see the second type of operation in a drilling, that is tapping operation. Now, this is a tapping tool where the cutting edges, you can see they are in a zigzag manner. Right? This operation, as if you see clearly, each of this, if you observe, if you see each of the edge particularly, this edge is resembling like a threading tool, right? So each edge of this is resembling like a threading tool. So if there are multiple like this, if there are multiple edges like this, then what is the output we'll be getting here? We'll be getting a thread, internal threads. So by using a tapping operation, we can produce internal threads in a hole. So internal threadings are produced by using a tapping operation. And if you see the other operation, that is counter boring operation. Now in a counter boring operation, now this operation is mostly meant for producing stepped diameter holes. This as we have performed, right? Stepped taper turning, step turning operation. Now, in the same way, in boring also, the holes to get large size and then smaller size and then smaller size holes. Now, in such type of operations or such reduction in diameters or stepped holes can be produced by using this counter boring tool. Counter boring is the operation which produces or which gives out stepped holes. Now all these operations which we will be seeing in the next video. Now here countersinking. Now countersinking is the operation which is meant for producing tapered stepped holes. If you want to finish the hole or to some length, if you want to produce a tapered section, right? Now, if you see screws or nuts which we will be placing inside the material or in a block of material, right? When you place the screw inside, you'll be observing, right? There will be a change in the diameter. Counter boring is the operation which produces a change in the diameter holes, right? Now using screw nuts, now the screw and nuts are available in different shapes and different sizes, right? Now some will be flat, a square, like circular, whereas some will be tapered, right? If you have observed, some will be in a tapered form. Now such type of pins or such type of screws and nuts are can be placed, screws can be placed by using this kind of operation. Now this is the operation which is meant for producing those type of profiles, right? So by using a countersinking operation we can produce a tapered hole, that is up to some depth we can make the hole tapered, right? The next one is center drilling operation. Now like in producing holes on a larger workpieces, if a large length workpiece is present, right? So in a large length workpiece, this center drill tool is mostly used like if you are drilling on a lathe machine. Like, so for example, if I have a workpiece, if I have a cylindrical rod like this, and I need to point the center, I need to center this whole diameter. Like if I want to center this. Now, in such cases, center drill is the one which will be producing a small to for the workpiece to be holded at that particular point. We'll be making a small depression at the center point. Now, this center drilling is the operation which is done to locate the center of the workpiece. Okay, so for while drilling in a lathe machine or while holding a longer length workpieces on a lathe machine, we'll be going first. Initially the center drilling is done to locate the center of that particular point. At that particular point a center hole, a depression will be done, and at there this tailstock will be holding the workpiece. Okay, so center drilling is mostly meant for locating the center point of that particular workpiece. And spot facing operation, like if you see from the figure, you can see when a drilling is done, when some drilling operation is done on a workpiece, there and the edges, like where adjacent to that hole, you can see some material which will be flowing here, right? There will be some irregularity at the edges because of the drilling of the hole. Some disturbance will be there, or some metal deposition, or some deposition in the sense some metal will be not in a proper way. So to finish such kind of surfaces we go for spot facing operation, right? So these are the different operations related to drilling. So before going to that, we'll be seeing the video. Counter counter sinking tool. Right. Sorry, counter. See here you can see by using that counter sinking tool, you can get a tapered finishing on the surface, or tapered up to some depth. We can produce a tapered section. Here you can see the how a tapping operation, how the material will be removed in this particular case. So here you can observe, depending on the type of the or shape that is provided on the uh, the thread shape which is provided on the tool, depending on that you get the different shapes of the chips. Whether it is whether the chip is removed in the form, material is removed in the form of fine small pieces, or whether it is removed in the form of like you can see spiral, right? So how it is removed, and that is dependent on this. Now here you can see how the material is getting stressed because of the tabs which are present on the surface, threads which are present. Now coming to the presentation, here there are different, as we have discussed in the last session, that drilling can also be performed by using a lathe machine. There are special drilling machines also, like drill presses, which are also used for doing the required operation. Like here we have drills. One is the upright drill press, where you can see here there will be a base with a table on which the workpiece will be mounted, and there will be a spindle which is mounted to the head or adjustable head, where you can give the feed to this, where the spindle will be holding the cutting tool or the drill bit, right? So the feed is given to this by adjust with this adjustable head. The tool can be adjusted. At the same time, it will also be rotating and doing the required job. And there are other radial drill presses, whereas the speciality of this radial drill press is that here, by this swiveling head, there is a swiveling head where it can rotate. The swiveling head will be rotating, by which you can place the tool at any angle at the desired angle, and do the drilling operation. Right. Also, it has X direction or the Z direction, feed direction. So at the same time, it has the feed motion. At the same time, it will also be having the rotary motion. And at the same time, it will also have the swiveling motion. This is the swiveling motion by which you can provide this movement, angular movement to the tool. And this is the work table on which the tool workpiece will be mounted. Right. Now these workpieces can be held by using vise or the holding devices. Work holding devices. Those can be by using a vise. You can hold the workpiece. By using a jig and fixture also, you can hold the workpieces. Whereas jigs and fixtures both are the same, but the main difference between a jig and a fixture is that jig jigs are used for holding the workpiece. At the same time, you can locate the workpiece. Location is possible by using a jig. Whereas fixture is the one only it is used for holding the workpiece. Now that is the main difference between a jig and a fixture. Now all these three types are used for holding the workpieces in a drilling press. Right. So next, before going to this milling operation, we would like to see the operation or different operations, how they are performed on how they are placed in a drilling press. This is a basic drilling operation to produce a circular hole. a reaming tool doing the operation. So as I have said that this operation is meant for only finishing a hole. As we know, finishing is nothing but removing the material in a very small amount. Now this is a boring tool. Counter boring tool, you can see. Counter sinking, you can see the tool is tapered. Tapping to produce internal threads. So here the spindle is the one which is holding the tool. Spot facing, as we have discussed, that is for finishing the already existing hole. So it finishes the surface. So this is about drilling operation. Next, coming to milling operation. Now milling uses multi-point cutting tool. Milling is an operation which uses multiple cutting edges. So here in this particular operation, the tool which is used has multiple cutting edges, and during the machining operation these multiple cutting edges will be participating in the material removal process. Now each teeth. Now these multiple cutting edges on the surface, they are called as teeth. Here in this particular figure you can see this is a milling cutter. Now it is called as a milling cutter which is used for milling operation. Now the teeth, each teeth will be acting like a single point cutting edge. Each teeth will be acting like a single point cutting edge, and in that way multiple edges will be participating in the material removal process. As multiple edges are participating in the material removal process, this particular operation is called as a multi-point cutting tool operation. Multi-point cutting tool operation. Right. Here now the tool will be, as you can see in the figure, that the tool will have multiple cutting edges which are there on the surface. Right. Now if the workpiece direction if the tool rotation and the workpiece axis are parallel to each other. If the workpiece axis rotational speed, now here also the tool will be rotating and it will be removing the material from the surface. Now if the workpiece axis, tool rotational axis and the workpiece axis are parallel to each other. If both are parallel to each other, like for example, if you take this, if I take this is the workpiece, so this is the workpiece, and if this is my cutter, right? Now, if the cutter rotational axis, and the workpiece axis are parallel to each other, then I call this as plane milling operation. Now, the teeth are present on the surface, on the periphery. The teeth are present on the periphery of the workpiece, periphery of the cutting tool. Then that is called as a plane milling or peripheral milling operation. It is called as a plane milling or peripheral milling operation. And there is other operation where we can see the other type is face milling operation. Face milling operation where the workpiece and the tool rotation, workpiece axis and the tool rotation are perpendicular to each other. If both are perpendicular to each other, I call this operation as a face milling operation. Now here the teeth can be present on the periphery of the tool. The teeth can be present on the periphery of the tool or they can also be present at the edge of the tool. They can also present on the edge of the tool. Whereas in a peripheral milling, the teeth are present on the surface. Now here in a face milling operation, the teeth can be either present on the surface or they can also be present in the edge at any edge of the tool. Now here the operation can be performed, will be performed like this. Whereas in a plane milling operation, the material removal will be happening on the surface. Whereas in a face milling operation, this will be performed in this direction. Alright? Now this is the difference on two different types of milling operations. Peripheral milling or plane milling operation and face milling operation. Now on which type of materials or on which type of cross sections can we perform a milling operation? What is the use of this milling operation? Now this milling operation is mainly performed on a flat workpieces. If the workpiece is a square block, square cross section or a rectangular cross section, on such workpieces we will be performing this milling operation to remove the material. Since those are large square blocks are present. Now such material like such workpieces are usually machined by using milling cutters, where the final cross section that is obtained is a square cross section. Like for example, if you take even by using even by using a you can ask me like even by using a lathe machine, by using a four jaw check, I can place a square block or a rectangular block. Right, there also I can perform by placing a independent four jaw chuck. By using that, I can hold the workpiece, a square workpiece, and then I can do the machining operation. In here also I am doing the same thing. What is the difference between these two? The main difference is that when you are performing the operation by using a lathe machine tool, where even though you are holding the initial cross section of the workpiece is square or a rectangular cross section, when you perform the machining or by using a single point cutting tool, when you do the machining operation, there the output of the cross section or at the end of the operation, you get a cylindrical or circular cross section. The end of the operation you will be getting a cylindrical or a circular cross section. Whereas in a milling operation, whatever the block which you take, whether it is a square cross section or a rectangular cross section, the output after machining you will be getting is a square or a rectangular cross section. The cross section will not be changing. Whereas in a lathe machine tool, even though you can hold the kind of workpiece, square or rectangular cross-section workpiece, but there the output which is received is of a the obtained is of a circular cross-section. That is the main reason we go for milling operation, where we use multiple cutting edges, a milling cutter, to do the operation. Right. So the two types of milling operations are plain milling and peripheral milling operation. Depending on the axis, how it is placed. If it is parallel to the workpiece, then it is called as a peripheral milling. If it is perpendicular, it is called as a face milling operation. Now there are different types of peripheral milling operations. Like in this present case, you can see the different types, that is a slab milling operation. Now, if you see all the cases, all of them they have parallel, the axis of this is placed parallel to the workpiece surface. Now, if you take the first one, slab milling operation, it is termed as a slab milling operation where the tool width is more than the workpiece width. This is a basic operation where the tool width will be more than or the tool width is larger than the workpiece width. Then we call it as a slab milling operation. If the tool width is smaller than the workpiece width, then it is called as a slot milling operation. It is called as a slot milling operation. Now by using this operation, we can, by using a slot milling operation, or it is also called as a slotting operation, by using this operation, we can make slots on the surfaces. Slots can be made on the surface. Now by reducing the length of this, the width of the cutter, you can even cut the workpiece, right? By reducing this width, by making it very thin, you can even cut the workpiece. Now that is operation is saw milling operation, where you can see by using a hacksaw, you can even cut the workpiece surface. That is an example of this slot milling operation, where the thickness of the cutter is much less. And here we have side milling operation. It is nothing but if the the tool is present or that is used for machining to one edge, we call it as a side milling operation. In this, if there are number of this thing, if there is one more, if both sides are performed by using two cutters, then we call it as a straddle milling operation. Say two sides cut with two different cutters. Different in the sense, if two cutters are placed to one holder, one spindle, then it is called as a straddle milling operation. If there are more than two, it is called as a gang milling operation. It is called as a gang milling operation. Right? So now as we are talking about this peripheral milling, where the axis of the tool will be parallel to the workpiece axis. Now in this present case, if you take, now how this, there are different forms of doing the operation. There are different forms of performing this peripheral milling operation. Now in this particular case, where you can see two forms, up milling and down milling, which are very important while performing the operation, right? Which one to choose, which one is best? Like if you see the up milling operation, the left one, which is up milling operation, where the up milling cutter, now same cutter is used, you can see workpiece and cutter both are the same, but the main difference between up milling and down milling is that if the feed direction, workpiece feed direction and the cutting tool motion are in opposite direction, then we call it as a up milling operation. Whereas if both the feed direction and the tool movement or tool rotational movement are in the same direction, then we call it as a down milling operation. That is the only difference. If you see clearly the picture, you can see in an up milling operation, the material removal will be happening from minimum to maximum. In an up milling operation, the material removal happens from minimum to maximum. So the material removal will be happening from minimum to, it will be digging the material, right? It digs the material from minimum it takes and maximum it comes out. Whereas in a down milling operation, you can see the material removal is maximum in the starting. In the starting it is maximum and it comes out to be minimum. It comes out to be minimum. So now what is the main difference? Like what is the disadvantage of this? What is the difference in this? Now if you see in this both the up milling and down milling operation, in an up milling operation you can see the length of the chip is more. The length of the chip is more. Whereas in a down milling operation the length is less. Length of the chip is less. The amount of tool contact, which means the time at which the tool is in contact with the workpiece, is larger in an up milling operation, whereas the time of contact is less. Which means what? That is, here the tool damage will be lesser in the case of down milling operation. The tool damage will be lesser in the case of down milling operation because the time of contact is less here. Since the time of contact is less, the damage that, no, when will the tool get damaged? It gets damaged only when the more the it is in the material removal process, then it gets more damaged. So here, since the time of contact between the tool and the workpiece is lesser in for a particular volume of material removal, this up milling down milling process, the tool will get less damage, whereas the damage of the tool life will be less in the case of up milling operation, right? And one more thing, one more difference, like if you see keenly, as the material here in an up milling operation, the feed motion is in this direction, workpiece feed, and this tool rotation is in this direction, right? Opposite direction. Now since the material is removed in the opposite direction, at the same time from minimum it is going for maximum. Now, since it is going from minimum to maximum, there you can see the lifting of the workpiece will be happening here. So, the lifting of the workpiece will be happening in this case, since the feed motion and the tool movement are in opposite direction. So, here for this upmilling operation, we need to have a very sturdy fixtures. So, more fixtures, more tool holding devices are much like fixtures are much more important, like the sturdiness is much important in the case of up milling process. We have to take more care on the fixing of the tool, whereas in a down milling operation, since the here you can see the feed direction is in this direction and the tool is also coming in this direction, large amount of force, the force which is acting on the workpiece, will be maintaining it to hold. So because of the cutting motion, the workpiece is held here. Right? That is, it is not acting in the opposite direction. So no much concentration on the holding devices is required in this particular case. Right? So since it is also contributing in as a part of, like these cutting forces are also acting as a part of holding the workpiece in the down milling operation. Right. Now that is one difference, and one more difference is if you see the upmilling operation, you can see there the tool is mostly moving on the machined surface, right? So by this the machined surface may also might get damaged, right? So that is the main difference between upmilling and downmilling operation. So the most preferable and most one economical one is downmilling operation, right? So mostly in most of the cases we go for downmilling operation. The next operation is, before going to the next type, we'll see a small video. This is a straddle milling operation. We'll see it once again. Where you can see this is a down milling operation. It's a straddle milling, it's a type of straddle milling operation where you can see two cutters are present at the edges. They are performing the operation at the edges. So the next type of milling operation is face milling operation. Now as we have discussed, if the tool axis is placed perpendicular to the workpiece axis, then it is called as a face milling operation. So now there are different types of face milling operations, like we have the conventional face milling operation, like straddle milling like we have the basic peripheral milling operation. Now this conventional face milling is nothing but if the tool diameter is more or tool width is more compared to the workpiece width, then it is a conventional face milling operation. And here partial face milling is if we are performing it only up to a certain width of the workpiece, then it is called as a partial face milling operation. And end milling operation is like it is same as slot milling operation where the width of the tool is much lesser compared to the workpiece width. Now here also this is used for producing slots. And here profile milling is nothing but it's a kind of end milling operation where the tool is used to produce a certain profile. Here you can see it is used for producing a certain profile on the surface, then it is called as a profile milling operation. Pocket milling is also a kind of end milling operation where you can see it is used for producing pockets on the surface. This is a pocket milling operation. And then again we have surface contouring operation. Now here in all the cases you can see in all the cases we have square edge tool. The edge of the tool is a square edge. Whereas if it is made of a ball shape, if the same thing is made of a ball shape, end milling cutter with a ball edge, then we call it as a surface contouring operation. Whereas different surface profiles are produced by using this surface contouring operation. Now before going to this, we'll see a small video showing the different types of milling operations. You can see this is a ball edge cutting tool. Okay, so next coming to the different milling machines. Now there are different types of milling machines. Like here the most common one is knee and column type milling machine, which is the basic type which uses a knee and a column. which uses a knee and a column, to which, like for a horizontal milling machine, like here you can see how the tool is mounted in a horizontal type of milling machine, and for a vertical milling machine, sorry, how the tool is mounted. So here you can see, here for an horizontal this thing, mm, the spindle will be attached to an arbor. An arbor is attached to a spindle on which the tool is mounted. Whereas it has the rotary motion, you can see it has a rotational motion. At the same time, the tool or the saddle knee on which a saddle is be placed, on which the workpiece will be placed, work table will be placed, on which the workpiece will be held, which has both x motion, y motion, and also the feed motion. For this particular operation, we have the x direction motion, y motion, and the z feed motion to the work table, whereas rotational motion is given to the tool. In the same way, here an arbor is not present. To the spindle only, the in a vertical milling machine, the spindle only the cutter is mounted, and it has the rotational motion, and all the other motions are given to the knee. Right? This is a basic type of milling machines. And there are special types of knee and column machines, whereas we have in a special type we have a swiveling head, that is universal milling machine, where the table is replaced by a rotary. The work table is placed or replaced by a rotary, where you can give rotational motion to the workpiece also. Along with the X, Y, Z direction motions, feed motions, we can also give rotary motion to the workpiece can be placed at a particular angle in this milling machine, universal milling machine. And we have a ram type machine, where the tool, instead of an arbor, we can have a ram on which the tool is mounted, right? Which has a swiveling head. We can adjust the tool movements. Now, along with it, we have simplex bed type. Now, this simplex bed type milling machines are usually meant for large size of blocks. For large size of blocks, we go for bed type milling machines. For machining a large size workpiece, we go for this bed type machine, where a large sturdy bed is maintained to hold the to overcome the large forces, cutting forces, mm, to absorb the large cutting forces. We have a large bed type milling machine. Now the feed is given to the work table or the workpiece, and also rotational motion is given to the spindle. Now the tool is mounted on the spindle. Now this is about the milling machines. This is about milling, drilling, and milling operations. Now in the next session, we'll be studying about the CNC machines. What are the unconventional CNC or advanced machines? How we'll be so far you have dealt with or you have seen the lathe manual machining process. In the next session, we'll be studying about the CNC, what are CNCs, and what are the unconventional machining process. Just an introduction to the unconventional machining process. And also we'll be writing a small program, and I'll be telling you how a program has to be written in a CNC machine by using CNC codes. Thank you.